For a motivating example, consider a command line order processing system. 3 operations must be supported: create an order, update the quantity ordered, and ship the order to the customer. The program must parse the command line arguments, then it must execute the command, whatever it is. Finally, it must notify the user of the results and log them for audit purposes. Keep in mind that other operations may be required later. For example, perhaps someone will request a delete order function. Let's take a look at one possible solution. For this demo, I will be using PyCharm from JetBrains, a popular Python IDE with plenty of help for the programmer. It comes in a few editions. I'll be using the free Community Edition. Let's take a brief tour around this IDE. Here is a typical PyCharm session. I have an example Python file in the editor which occupies the main portion of the screen. Open files are arranged in tabs above the file display, and it's easy to move between them with a single mouse click. The left window shows the project structure. It's easy to open and close subfolders and move between files. This window can also be hidden by clicking the Hide icon. Now, you might have noticed a little orange light bulb near the definition of method f. If I hover over that, a little blue arrow pops up, and if I click the arrow, PyCharm gives suggestions for possible improvements. We won't take that suggestion here. Now, we'd like to run this program. Just above the Edit window, there are 2 icons, a green arrow and a green bug. If I hover over the green arrow, PyCharm offers to run the program. Similarly, if I hover over the bug, PyCharm offers to put it in debug mode. But before we run it, let's add a little code so it does more than just define a class. First, we'll instantiate a class. Then we'll obtain the results by running method f. And notice how PyCharm does a lot of autocomplete work for us. Finally, we'll print out the results. Now we have a complete program. Doesn't do much, but it's complete. So let's run it. When it finishes, the Run window opens up at the bottom showing the results. Note that there are other windows at the bottom as well, including a Python console for interactive use, a terminal window for an operating system shell, a to-do list, and a debug window for when you're in debug mode. Like the left window, the bottom window can also be hidden. Oh, but before we do, note that our program actually worked. We obtained the results we wanted. Now, let's use PyCharm to try to solve our order command processor problem. The first attempt starts off with a pair of imports, one to give us access to command line arguments, and another to import the class created to do the actual work of executing the commands. The program first checks to see if there are any commands at all, and prints a short usage summary if none are found. If there is a command, the program instantiates a new command executor class and gives it the command to run. Let's look at that class. Okay, the command executor class is a little big, probably too big. Note that the execute command method uses an if, elif, else statement to dispatch helper methods. You can see that only the update quantity helper method is implemented so far. It simulates a current quantity, called old value, just for testing. Well, let's run this program and see if it works. The first time, it just prints the usage summary, since we've given it no command to process. However, in PyCharm, we can do that in the Run debug configuration. So run, edit configurations, put in a new command. OK that. Let's run it again. We can see now the results of the execution. The update quantity method did exactly what we wanted. Apparently, we wanted to order Pi. Now back in the command executor class, notice again the if, elif, else statement. This sort of thing is usually a sign that there may be a better way. In fact, the strategy pattern also helps with a similar class of problems, though it's not a good fit here since each helper method has a different signature. This class also has too many concerns. It both parses the arguments and handles invalid ones, and then executes them. Also, adding, changing, or deleting commands would require changing this class, in violation of the open-closed principle. So what kinds of problems did we find in our first attempt? Well, there's a violation of the single responsibility principle. The command executor class parses commands and then processes them. These concerns should be separated. The class also violates the open-closed principle, since we would have to change it to add new commands or change or remove existing ones. The main program also violates the dependency inversion principle, since it depends upon the implementation of the execute command method in the command executor class. We also have a long list of if, elif, else clauses that's a bit fragile and a little hard on the eyes. In fact, whenever you see code like this, it's good to ask yourself if this might be done better using the command pattern. Let's see now how that design pattern addresses these issues.